Dear students, under the topic center of mass, here we are going to find the center of mass of a solid right circular cone of height h. So we have the following assumptions. O is the vertex of the cone. So this is the vertex of the cone which is taken as the point O. OA is the axis of the cone which is taken as the x-axis. So the line OA is the axis of the cone which is symmetrical about the x-axis. So A is the radius of the cone, that is the base radius is called the radius of the cone which is taken as A. So this line, for example, if you consider this point as B, this AB, the line AB is the radius A. So h is the height of the cone, that is the length OA is the height of the cone. So that is taken as h. So AB is the radius of the cone which is equal to A, and OA is the height of the cone which is equal to h. Next, we consider the mass per unit volume of this cone which is rho. That is, for 1 unit of the volume, the mass is taken as rho. Next, we have to find the total volume of the cone. So, by the formula, we know that the volume of the cone is 1 by 3 pi r square h, where r is the radius, h is the height. Now, using that formula here, we get the volume of the cone to be equal to 1 by 3 pi r square. Here r is the radius. What is the radius? It is a. So it is a square multiplied with the height. Here the height is h. So the volume of the cone is 1 by 3 pi a square h. Now we will find the mass of the cone. The mass of the cone capital M is given by volume of the cone multiplied with mass per unit volume. Now what is the volume of the cone? It is 1 by 3 pi a square h. And what is mass per unit volume? It is rho. Rho is mass per unit volume. So when we multiply this, we get 1 by 3 pi a square h rho as capital M. So therefore the value of capital M is equal to 1 by 3 pi a square h rho. We now divide this cone into thin circular laminae perpendicular to the axis OA. So this is the axis OA. So perpendicular to this axis is this direction. So in this direction we are dividing this cone into thin circular lamina. So one of the circular lamina is shown here. It is in the shape of a cylinder, a thin cylinder which will be of a very negligible height, and that height we will be taking as delta x. So the height of the cylinder is taken as delta x, and this cylinder, that is this circular lamina, is taken at a distance x, for that is for the distance between, for example, if I take this point as C and this as D. So if this point is C and this point is D, the distance OC is taken as the value x. That is, we are considering one such lamina at a distance x from the point O. And this lamina is a circular lamina which is of height delta x. So putting that into words, we have here, divide the cone into thin circular laminae perpendicular to its axis OA. So we have divided it and we have considered one such lamina. So then consider the lamina whose distance from the vertex O is x and its thickness is delta x. So that is what I showed here. So this is one such lamina which is taken at a distance x from the vertex O, and the thickness is delta x. Okay. And the thickness of the lamina is equal to what? It will become the height of the lamina, which is equal to delta x. Now for this lamina, the next step is we have to find the radius of this lamina. So what is the radius of this lamina? The distance CD will give us the radius of this lamina. Now we have to find the distance CD. How to calculate the value of CD? This we will be doing by using the concept of similar triangles. For example, I will be considering the triangle OAB. So this triangle alone I am considering. Now this CD we have. So by using the concept of similar triangles, the distance OC divided by the distance OA will be equal to CD divided by AB. This is by the concept of similar triangles. I will take the triangle separately and I will draw and show you. Now I have taken and drawn the triangle separately. This is the point O, this is the point A, this is the point C. So we have taken the triangle OAB. Now this point is taken as C and this point is D. So this triangle I have taken and I have shown you separately. Now we know that the distance OA is what? Height H. And the distance OC is what? The length X that we have taken. This is the radius that we have to find, and this is the base radius of the cone, which is A. So now in order to find CD, we will be using the formula of similar triangles, that is CD divided by this distance divided by AB, this distance. So AB will be equal to CD is the smallest distance. So similarly, the smallest distance here is OC. So OC divided by OA. So we are going to use this similar triangle method and we are going to find the value of CD, which will give us the radius of the circular lamina that we have considered. So let us see how to do that. Now we will I have taken and written that separately. CD is what we have to calculate, and CD by what is AB? It is small a, is equal to OC is X divided by OA is H. And so from this we obtain the value of CD to be equal to AX divided by H. So which will give us the radius of the lamina. So therefore the radius of the lamina is AX by H. Next we have to find the volume of the lamina. So the formula for the volume of the lamina is pi r square h, because I told you the lamina is a thin cylinder. It is cylindrical in shape. The volume formula is pi r square h, where r will be the radius. But what is the radius of the lamina? Ax by h. So it will be Ax by h the whole squared pi r square h. Height of the lamina, that is the thickness of the lamina, is the height of the lamina. Already we saw that. See, here we have written, that is the thickness of the lamina is equal to the height of the lamina, which is delta x. So using that we have to multiply this with delta x, and so therefore the volume will be equal to pi a square x square divided by h squared multiplied with delta x. So this is the volume of the lamina. We now next have to find the mass of the lamina. So the mass of the lamina dm is given by volume of the lamina multiplied with mass per unit volume. So therefore the value of dm will be equal to, the volume of the lamina is pi a square x square by h square delta x multiplied with the mass per unit volume is what we have seen, that the mass per unit volume is rho. We have taken it to be rho. So this we have to take and substitute. So multiplied with rho. So therefore the value of dm is this. So now if the mass center is the point on the axis at a distance x from O, thus if the mass center of the cone is G, then we will have OG to be equal to integral x dm the whole divided by capital M, where x will vary from 0 to h, because the height of the cone is h and we have to find the mass center for the cone. So it has to be integrated from 0 to a. But what is that distance? It is h. So we take this point as 0 comma 0 and this point as h comma 0, and therefore it has to be integrated from 0 to h. And so we have the value of OG to be equal to integral 0 to h x multiplied with dm, which is pi a squared x squared by h squared delta x becomes dx multiplied by rho. A whole divided by capital M. So what is capital M that we have obtained? We have obtained it as 1 by 3 pi a square h rho. So this we will make the substitution over there. So substituting this m over there, we get 1 by 3 pi a square h rho. So we can see that rho and rho gets cancelled, and then a square gets cancelled, pi also gets cancelled, and we will be this 3 will go to the numerator. So this will be equal to 3 by h, and we have h square inside, and so that comes outside and becomes h cube. H square gets multiplied with this h, and it becomes h cube, and integral 0 to h, x multiplies with x square and it becomes x cube dx. And further, this on integration will give us 3 by h cube, and here the integration, after integration, x cube becomes x power 4 by 4, and this is between the limits 0 and h. Now substituting the upper limit and the lower limit, we get 3 by h cube multiplied with the upper limit is h power 4 by 4 minus the lower limit, it becomes 0, and so that is equal to h cube, and here also h cube gets cancelled and we have only one h, and so the answer will be 3h by 4. So therefore the center of mass for a solid right circular cone with height h is 3h by 4. So I hope that you would have understood how to find the center of mass for a solid right circular cone. In our next video, we will find the center of mass for a hemispherical shell and a hollow right circular cone. Thank you.